Okay, so whether you ladies tune into this, whether it's sometime today or not likely tomorrow or something, or maybe Friday, I don't know, whether you're keeping up with your homework. We're going to try to just keep this really short for each and every day because wish you the best this weekend. And I know an important part of your high school experience is taking place, but then we don't want to retract from this as well. So we'll try to keep this as short as possible. So a couple of things I wanted to put up on the board just to kind of point you in the right direction is this is very similar to number 5 on your paper, okay? And then we have a structure down here that we'll talk about here in just a moment. Okay, so one of the things that we see with this structure, okay, and a lot of things are still going to be the same when we're naming some of these compounds. What would be the first thing that you would do? Okay, when you say that you're close, we're talking about this one though. Okay, so you're correct. We're looking at our parent chain. So we know that we have this, okay? But the confusing part about that is, in this, it's not a coincidence that on your paper you see 5 and 6 in a row like that. Because what we're trying to do is illustrate how you would actually name these. Because now we got 2 different organic families on here. And with this would take priority because we're in the not because we're in the alcohol chapter, but because alcohols or hydroxy groups would take priority over a double bond here. So at some point we know we're going to have E and E on here because that's what a double bond illustrates. And then we know we're going to have this somewhere as well because we're denoting an alcohol. Okay. So now that we have our parent chain established, okay, and when we look at number 6, where you have the name and you have to draw out the structure, okay, so according to how you're drawing number 6, okay, what would go on the right-hand side here, naming our alcohol or naming our alkene? On the right side here. Okay, so the alcohol would be named over here, our alkene would be named over here. So in this case, okay, and when we say what takes priority over the other, the numbering is certainly going to favor this. So we want to try to keep this as simple as possible. But like, what was it? On Monday we said, if there's nothing written after if there's nothing written after a number, it's telling you one of 2 things. Either where a double bond is located or an organic family. So here we have both of those. So if we were going to name this, where is our double bond located? So this could maybe be a little tricky here. Are we going to go right to left or left to right? And that would be correct, okay, because from prior knowledge we would say that wouldn't make any difference because after our 3rd carbon is where this double bond is located. But the problem with that is we have this alcohol group right here, so therefore we have to go in this direction. So then our double bond is located after which carbon? Okay, so we're going this way. After our 3rd one, we have 3 dash. Now, if this was not on here, then it would be really simple. I think we would all agree. Because then, what would our suffix be? Right, it would just be 3-hexene. But the problem is we got these 2 organic families on here. So how do we go about naming those? Now when we use number 6 as a guide, we're going to account for both of them. So we're going to take care of the E and he okay? Although we're not going to put an E on here. Then, again, using number 6 as a road map, what would come after this N? Okay, it would be your, not just L, okay? So where is that alcohol located, on which carbon? Okay, so then we would go 3-hexene dash 2 dash what then? How do we denote alcohols? Yeah, with this, okay? So there it is. 3-hexene dash 2 dash all. Although I didn't. See, here we're making reference to you ladies, and look at, we're going uphill, so we're just being optimistic here as well. So I'm going to rewrite that because 3-hexene dash 2 dash all. There we go. Doesn't take away from our optimism here, though. No, nope, we would not put an S in front of there at all, okay? Because you're thinking this is a secondary alcohol, which it is, but that's just how we classify them, not how we name them, all right? So then, hopefully, with number 5 then, you're going to have the same number drawn twice. So what we could do then, okay, is 1, 2, 3, 1, 2, 3. Then we've got that, then we're going to put an OH group up here. And then I think we can get rid of that. So then hopefully that makes that just a little more simpler. Same rules apply. You're going to find your longest continuous chain, which we know it's 5 now, not 6. Okay? And then what would go in front of your PENT? Because where's that double bond located? Are we going to go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5? It's a little tricky because it's kind of a trick question. It doesn't matter because you're going to get the same number. So then what would you put in front of that P? What number? Yeah, you would put 3 because then you're denoting where that double bond is because it's right there because that's on the left side of the parent chain. Then your OL would come after that. So therefore, that would leave you with 3-pentene dash 3 dash. So we're here, 3 dash all. Yep, that's how you do number 5. Okay, and then when you get to the reactions, okay, now this exact compound isn't on there, but there's something fairly similar. So when we're reacting alcohols, the first thing you're going to want to do is establish what type of alcohol is this. So now it can be tricky, I understand that, because remember at each one of these junctions there is a carbon atom. Okay, so since this OH group attaches this carbon, how many other carbons are attached to this one? So there's one down here, there's one back here. Is that it? And then there's one over here. That's a carbon-to-carbon bond too. So if this carbon is attached to 3 other carbons, yep, this is a tertiary alcohol. And when that, we talk about tertiary alcohols for oxidations, because how do we know we're oxidizing something? It has to be this, or I'll keep the stronger ones together, or it could be one of the less, it's just as well known, it's just not as as strong as the other two. Oops, this is a 2, that's a 4. Do tertiary alcohols react? They can if you're going to do what with them? Oxidize them or dehydrate them. They will dehydrate, but will they oxidize? No, this cannot be oxidized. Okay, so hopefully that can kind of point you in the right direction. Like I said, we don't want to spend a whole lot of time. We just have mechanisms on the board. I think about 11 minutes, 10 and a half minutes right now. We'll just do a little bit tomorrow and then wrap up the rest when we're all together again. Anything else? So when we look at number 13, okay. Well, we had heard number 13, but then we changed our mind on that. We thought, well, maybe we should rather look at number 9. Okay, so we'll go ahead and do that quickly, and then that will be it for today. So number 9, 1, 2, 3, 4, which is not a number we want to have you ladies have over the. I mean, yeah, they're set for, but we don't want 4 hits. Certainly don't want that. Okay, so what are we trying to do with this alcohol in number 9? Nope, it just says, for the following, complete the reaction. Some may have more than one product. Okay, so we have this alcohol here, and then what type of reagent do we have? Is this dehydration or is this oxidation? It is an oxidizing agent, so therefore we need to establish, okay, this alcohol attaches to this carbon, okay? So then when we say X marks the spot, how many other carbons are attached to this one? So it attaches to this one, okay? So that must mean where X marks the spot, attaching to only one other carbon makes this a what type then? Okay, it would be a primary alcohol, so we'll just put a little P there for primary. Okay, and then what you could do is, that's why we have those charts that were established or handed out to you, if you want to get those out, is now that we have that established, this is a primary alcohol, and according to your flow chart, how many products are we going to get? We are going to get 2, but not at the same time, because what this is going to state, okay, there's probably an arrow here, and then what might it say above that arrow? Okay, and it's probably going to say stage 1, and I think it just says that. Okay, so primary alcohols in stage 1 get oxidized to, what would that possibly be? The organic family. Close. Is now that we've established this is going to go through stage 1. It's going to form an aldehyde. Then, if this was K2CR2O4, we would be done. But since we have this stronger oxidizing agent, this just keeps right on chugging, and then it probably says stage 2, and then what does this form in stage 2? Yeah, it's going to go from a primary alcohol in stage 1 to an aldehyde. It keeps right on going because of this oxidizing agent, and then forms, like you correctly said, an acid. Okay, so We will continue with this tomorrow. We'll catch up to you next time.